to become celebrities to turn your camera off. And finally, note that most, if not all, of the presentations will be made available through the project website following this event. I think I've said it all for now. And with this, I'll give the floor to Dr. Andrew Cobley from Coventry University, who will introduce the session and who is our principal investigator in MATUROLIFE. Andy, you have the floor, please.
Okay, thanks very much, Stacey. Okay, can everybody see that? Yeah, okay. So, MATUROLIFE, as Stacey mentioned, just to give the sort of bare facts about MATUROLIFE, it was a €6 million project, originally due to run for 36 months. It's been extended by 5 months. There's no prizes for guessing why. We were obviously hit by the pandemic, and that caused a number of delays, as everybody will understand. It's an Horizon 2020 project funded by the European Commission, and the overall lead is Coventry University. So it's a big consortium. We have 20 partners from 9 EU countries. And the map there shows the spread across Europe of those countries. I'm the principal investigator for the project, and my co-principal investigator is Professor Louise Moody. So I thought I'd start actually by almost going right back to the beginning. MATUROLIFE, the acronym actually stands for Metallization of Textiles to make urban living for older people more independent and fashionable. And I think I deserve a pat on the back actually for coming up with that acronym. I've had many acronyms over the years for projects, and I think that's the best one I've come up with. And this slide actually showed at the kickoff meeting of MATUROLIFE, and I think it's still quite relevant to describe what the project was all about. The idea really was not just to do a purely materials and science-based project, but also to get involved or have a very, very strong design element to the project. And in that way, add value to the outputs that we produce, and hopefully you'll see that today. So overall, as Stacey said, we wanted to produce aesthetically pleasing functional products for assistive technology, making urban living for older people easier and more independent. And the background to that is obviously the aging population. There's a number of assistive technologies out there. I mean, one common one is a fall alarm or panic button. This often takes the form of, it might be a pendant with a big red button on it. Now that's functional, it works, but it doesn't actually look very nice. There's no aesthetics to that at all. And it also immediately, if you're wearing one of those sort of things, it immediately labels you as older, vulnerable. So as I say, the aim of this project was to take into account people's feelings, or older people's feelings, and thoughts, and work with them to design assistive technology. So as I mentioned, as you'll see today, we've done user-centered design, or we've incorporated user-centered design. We've carried out co-creation workshops with older adults, and through that we produced concept prototypes. On the other side of the project, if you like, on the materials side, we've done some really good electrochemistry, material science. We've got involved with printing technology, and we've developed E-Textiles. Both those sides of the project, if you like, have been brought together through electronic integration to produce our 3 prototypes, one in footwear, one in furniture, and one in clothing. So you will learn more about those today. So finally, the aims of today's event, well, we'd like to showcase the work carried out in MATUROLIFE. As Stacey said, we want your opinions too on those prototypes. And we'd like an external perspective on the opportunities for e-textiles and assistive technology, particularly in relation to the silver economy, but also more widely too. Also, if you see any potential here for partnering, then please let us know, or subjects for further projects, or indeed commercial opportunities. But perhaps most of all, we hope you have an enjoyable meeting and an interesting morning. So with that, I'll hand back to Stacey.
Thank you, Andy, for this useful introduction to the project. And now I'd like to give the floor to our keynote speaker, Mrs. Mercadier-Saflix, who is the founder and CEO of En Mode Création, which is a consultancy company that specializes in the social and societal impact of the fashion and clothing industry. So very interesting topics. And Mrs. Mercadier-Saflix will help frame the discussion by reminding us of not only the challenges that arise as a result of demographic aging in Europe, but also the potential economic opportunity it brings about. So Mrs. Mercadier-Saflix, you have the floor, please.
Thank you so much. Yes, thank you, Jennifer, for your help. So, hello, everybody. I'm very happy to be here. Before starting, I would like to thank you, all of you, and especially Mr. Pascal Negret, to have invited me today. It's a great honor for me to open this workshop of MATUROLIFE project. As you said, I have founded En Mode Création in 2019, and it's a consulting agency. So the purpose of En Mode Création is to develop sustainable strategies with professionals of fashion and design industries to meet current societal challenges as ecological transition, social and environmental impact, diversity and demographic transition. For a long time, committed to the socio-economic challenges of the demographic transition, my approach of the silver economy has always been to impulse a more creative, innovative and positive vision in line with the expectation of the new generations of over 60. Today, my presentation is divided in two parts. First, I will do a presentation of the strategic challenges of the silver economy sector and the market development prospect. Second, I would like to give my testimony as a member of the expert panel on the MATUROLIFE project. So first slide, yes. Aging is one of the biggest trends humanity is facing. It will affect not only Europe, but has worldwide implications. In the next 40 years, the senior population, over 65 years old, will increase in Europe to nearly 30%. The question of the anticipation of this aging is now behind us, but the current responses are not sufficient and the latent needs have not been heard enough. As an example, the first will of senior is to age at home. Slide 2. The major change in the next 10 years will go beyond our simple wish to remain healthy. The desire to remain autonomous and efficient throughout our life will become a market priority. We will witness an evolution towards a new idea of aging, where seniors wish to stay healthy, strong, and active throughout their life. We can expect a dramatic increase in customized, self-managed, or connected solutions, which will allow seniors to continue to live at home. Market influence will drive the implementation of all these developments in line with the consumer's demand to not only maintain their physical, mental, and social well-being, but also to improve it. Slide 3, please. The potential risks for health systems are huge, but so are the opportunities to develop new products in the area of healthy aging and well-being. In Europe, for example, people over 60 years old will account for half of overall household spending, and in addition, their main focus will be on health. In the last 2 years of our lives, we generally spend over 80% of the total medical spend of our entire lifetime. Therefore, it will be very important to invent new models and technologies that will reduce the cost of care and treatments and include policymakers, innovators, and industry experts in the discussions. The priority is to maintain quality of life on top of our agenda. 8 years after the launch of the sector, at the border between connected objects, collaborative platform, e-health, and the development of innovative medical devices, the silver economic ecosystem brings together promising startups. Slide 4, please. The launch of this sector has highlighted this need for innovation, but also the potential of the market. The silver economy is estimated at 130 billion euros in 2030, according to the CREDOC. 3 main areas of intervention are concerned. Startups acting to help seniors be autonomous at home. Startups encouraging the maintenance of the social bonds of the elderly and their interaction with caregivers and with other generations. Startups active in improving the management of EHPAD and in the development of new medical devices. Slide 5, please. Developing innovative products is, of course, a great opportunity and a necessity to meet the challenges of the sector. But it's important to not forget the design. Until now, design was often forgotten by the silver economy, more focused on the usage and the functionality of the products or the services, and not on the beauty or, as we said in fashion, the desirability of the product. Of course, the technical features are a priority because the products have to be easy to use and particularly secure for potentially fragile people. But even for old persons, the aesthetic is crucial. Nobody wants to wear or live without design products. Providers need to reinvent constantly their offer. Increasing innovation and improved design will help them to diversify in this highly competitive environment. To conclude, I would like to bring my testimony. It's, as I said before, it's for all these reasons that the MATUROLIFE project was for me a very interesting challenge and an opportunity to see if the combination between design and useful products for silver people could be possible. As I said in my presentation, I observed that the design has been often forgotten by the silver economy. It's why I think that the MATUROLIFE project is very innovative. And I'm very happy to have participated during this year. Today, I think that it's an important day because we will see the concrete results of this program and of your work. Bringing out this project was a big challenge during the pandemic, but you succeeded. I'm so satisfied because you show us that it's possible to create products which are useful and well designed. The expertise you may have acquired could be very useful for the silver economic sector in Europe, and of course, it will be an opportunity for the new generation of seniors. It's certain that the new generation of seniors don't want to be stigmatized by age. So you need to diffuse your vision and your expertise the most largely as possible, especially to the startup who wanted to enter this market. I would also like to mention that it was important to me to invite Pascal Negret to discover the University of Technology in Troyes, which has obtained an European label last year and to visit their living lab. It was also the occasion to meet Mr. Thibaut Vigier, the manager of the foundation, Dr. Dimitri Voilmy, researcher and the manager of the living lab Active Aging, and Dr. Alix Kerr, Silvertech researcher. As you will see later in the video Pascal Négret has made, the University of Troyes is specialized in research in the silver economy, but what is also very interesting is that on the same campus there is a design school. So implementing the European project of MATUROLIFE with other universities and, for example, the University of Troyes could be also an interesting perspective. To conclude, I would like to congratulate again all the members of this project. And I would say that even if the program and our workshop today marks the end of the program, I hope that MATUROLIFE will be a beginning and on something and not an end. So why not a MATUROLIFE season 2? Thank you for your attention.
Thanks a million, Mrs. Mercadier-Saflix, for your presentation and your enthusiasm and your great support as well. And for a very useful depiction of the desired outcomes. And when it comes to MATUROLIFE, it was about developing products that do not only meet the need of all the people, but are also appealing, so keeping people healthy, autonomous, and are appealing to people, attractive.
Yes.
So it is now time to discuss how we have managed to achieve these objectives and to what extent we've managed to achieve these objectives as part of MATUROLIFE. And to do so, we will start at square one, which is the square one of the fabrication of E-Textiles, that is printing and plating. And so I'll pass the floor again to my colleagues, Andy Cobley, who is accompanied by Dr. Neil Chilton, the technical director at Printed Electronics Limited. So you have the floor. And let me take this opportunity to remind the audience to post their questions and comments, if any, through the chat box, please. Thank you.
Okay, so I'm going to show a short video to start with, which shows some of the procedures we've carried out on the more material side of the project, if you like. And we'll go into a bit more depth after that in a presentation. So I'll just try and get that ready. Okay, can everybody see that?
Not yet.
Not yet, no.
No, okay. Can you see that?
Not yet.
Not yet, Andy. You might need to stop share and then reshare.
Okay. How's that? Nope.
No.
Okay, let's try one last time.
Yes.
Ah,
Yeah.
excellent. Okay.
Mon portable, là. Tu peux me passer mon portable?
Andy, is
Through
there,
Andy.
is there sound to your video?
No, I'm afraid not.
Okay, right.
But
Okay.
there is in some places. This is the, obviously this is the reaction to produce the copper nanoparticles. This is now, once the copper nanoparticles have been made, they come to Coventry University where we do further dispersion work. So this is showing, as you can see, this is the ultrasonic dispersion of the copper nanoparticles. Coventry then did some work to do some early work on a formulation to produce a copper nanoparticle catalyst. This shows the printing of that catalyst. So once we've printed the catalyst, we then do plating, electroless copper plating. So this was laboratory scale work. And one of the ways we can tell whether the reaction has happened is by looking for hydrogen evolution. So if you look carefully there, you can see gassing. So further formulation of the ink then carried out at printed electronics. So this is showing the printing of the insole, printing of the catalyst for the insole. And we'll talk about this a bit more in the actual presentation I'm about to give. This shows printing of the clothing, or part of the printing of the clothing prototype. Again, obviously this is speeded up. So once the textiles have been printed with the catalyst, so you've seen here really that from the work done at Plasma Chem, producing the copper nanoparticles, through laboratory trials at Coventry, further printing trials at PEL, and then plating at Bertin-Aubert. We've gone from benchtop to pilot line to be able to produce our E-Textiles. Okay, so I'll go into a little bit more detail with presentation. Okay, can everybody see this? No?
No.
Okay. Can you see it now? Yeah.
Yeah, we can see it now.
Good. Okay. Okay, so to go into a bit more detail about what we've just seen, when we started MATUROLIFE, the way we wanted to make our E-Textiles or smart textiles, if you like, was using electroless copper plating. The idea here was, by using electroless copper plating, we wanted to be able to completely coat the fibers within the textile with copper. And in that way, we wanted to produce a truly multifunctional material. So what I mean by that is that the electroless copper coating is relatively thin. It's about 0.5 to 2.5 microns. So although we've now introduced connectivity and conductivity to the textile, it doesn't hugely change the properties of the fibers within the textile. So the hope is that because we're not introducing metal wires, there's no direct printing of silver. The hope is that the feel and drape of the textile is maintained. It's still going to remain very flexible and bendable. So why did we choose electroless plating? Well, one of the aspects of electroless plating is that to get copper deposition, you need to use a catalyst. And what that means is that you will only get copper deposited where you put the catalyst. So it's a very good way of getting selective deposition on a substrate, and in this case on our textile. So we wanted to try and develop a catalyst that we could print, and then that would enable us to produce electronic connectors, sensors, circuits on our textile. Now, anybody that knows anything about electroless plating will know that the catalyst that has been used for probably 60+ years is palladium. So you might wonder why we need an alternative to palladium. The reason why is because it's very expensive. As you can see from these tables and costs, indeed, palladium has actually increased, almost trebled in price since the start of the MATUROLIFE product. So one of the potential alternatives was copper. Copper is relatively cheap, it's earth abundant. And indeed, some work done at Coventry University over 10 years ago now had actually shown that copper nanoparticles can catalyze electroless copper plating. This is on the right is a cyclic voltammogram. This was produced using an electrode made of copper nanoparticles. And the bump in this is the oxidation of formaldehyde. And the importance of that is that this is the key step in the deposition reaction. So this really proved that copper nanoparticles could catalyze electroless copper plating. So at the start of the project, a key objective of MATUROLIFE was to develop a printable copper nanoparticle catalyst to enable the selective metallization of textiles. And that work, as we saw in the video, began at PlasmaChem with the synthesis of copper nanoparticles. But it was also important to ensure that those copper nanoparticles were stable and well dispersed. And the way of doing that is to introduce ligands, which these kind of act as a shell around the copper nanoparticles, and they keep them apart. So PlasmaChem did a lot of work looking at a range of ligands that could achieve a stable dispersion. And three that looked very promising were APTS, oleic acid, and polyacrylic acid. So then this work then came to Coventry. These copper nanoparticles came to Coventry, and we did work to try and assess the ability of these various copper nanoparticle dispersions to produce a good electroless copper deposit. So this shows one of the textile before plating. We compared our catalyst with the standard palladium catalyst. The standard palladium catalyst gives us this nice copper uniform deposit. We also compared with silver, and again, you get a very similar, nice uniform deposit of copper. But with our copper nanoparticle catalysts that were functionalized with APTS and oleic acid, the coating is a bit patchy, it's not completely uniform. However, when we used the copper nanoparticle polyacrylic acid stabilized catalyst, we again get a nice uniform copper deposit, similar to the palladium and the silver catalyst. We did some scanning electron microscopy on the fibers or the coated fibers. So scanning electron microscopy allows you to look at the textiles under very high magnification. Because of how this technique works, the pictures come out in grayscale. And so although these fibers look like a silvery gray color, they are actually coated with copper. So again, with the palladium catalyst and the silver catalyst, we get a very uniform deposit of copper across the fibers. But again, with the copper nanoparticle catalyst stabilized with ATPS or oleic acid, the coating is not so good. There's areas that haven't been coated. And for the oleic acid, we get this slightly nodular deposit, which isn't desirable. However, again, if we use copper nanoparticles stabilized with polyacrylic acid, we get a very nice uniform deposit. We did a whole range of tests, but this is just one of them. This is sheet resistance. So this again is the sheet resistance of the copper deposit we got using our copper nanoparticle polyacrylic acid catalyst. And actually we got resistances that were actually lower than the coatings produced using palladium or silver as a catalyst. I just wanted to pop this in as a bit of a stop press, as a bit of a stop press slide. We're actually carrying out some antibacterial testing at the moment. And although these are very, very preliminary results, we've subjected our copper-coated textiles to a bacteria, this Staphylococcus aureus bacteria. And the uncoated textile, hopefully you can see, has got growth of bacteria, whereas the other three that are all coated with electroless copper have come out with no growth of bacteria. So as I say, it's very, very preliminary results. We need to do a lot more testing yet, but that looks quite promising. So we basically determined that the copper nanoparticle stabilized with polyacrylic acid produced a very good copper deposit. And so we used this to do some very basic formulations so that we could print it. And you can see this was the type of, well, this is after printing and plating. This was the type of copper deposit we got on the textiles. It's not perfect, it's pretty good, but it's not quite perfect. There's a bit of bleed, and the resolution isn't great. So this was the point at which we handed things over to PEL, and I'll let Neil take over the presentation from here. Neil?
Thanks, Andy. As Andy's described, and as you saw in the videos, the approach taken to depositing the catalyst down has been with inkjet printing. And one of the really important things about inkjet printing is that it needs to be reliable. And as you know from your inkjet printers at home, if you get blocked nozzles and lines on your images as you're printing your documents out, that obviously would be a major defect if you're trying to print electronics. So a really key part of this is to create an ink which was stable, which doesn't block the nozzles so much, and allows you to print for long periods of time. Because as you also saw in the video, some of these images that we printed for the demonstrators for the MATUROLIFE project are quite large, actually. So the work on modifying the ink that was initialized at Coventry into a more printable and more potentially commercializable version of the ink was done with my colleague Claire, who's based down in our Cambridge facility, in creating a sort of more printable version of the ink, but keeping the same fundamental characteristics of it being a copper nanoparticle based ink. So adding the secret sauce that makes an ink a good printable material. The other aspect to the work that we've done here that's quite apparent is to find a combination of a treatment, which again, we've done very closely with Coventry University, a combination of a treatment of the fabric surface together with the ink, which allows the ink to go down and to set on the surface in the position it's printed. So you get a nice quality image that represents what you want to achieve as a electric circuit later. So we managed to reduce the bleed, and it was nicely conductive after plating. Next slide, please, Andy.
5 minutes left, please, Neil.
Okay, great. So this is just a video. You've seen part of this already. If you can click play on that, Andy, then this is just a sped up video of printing on the PEL pilot line. And the type of inkjet print head that's used here is very similar to the type of inkjet print head you may use in your home applications and commercial applications. And the reason for choosing that type of print head is because that's very easy to scale that up to commercial applications. It's already an inkjet head type which is used for printing on packaging and is able to do large area. Essentially, we print stuff, and at the end of the day, you end up with this image here. So this is a close-up image of the copper catalyst copper catalyst as printed on the fibers. And the nice thing you can see there is that where we print the catalyst, it stays just in the area where it's printed. And it coats the entire fabric surface. And then later on, when we electrolyse plate that, that line will become conductive, and the white stuff around it will stay white and will stay like fabric. And therefore, the feel and drape of the fabric is maintained. Another thing to quickly point out here, there's a lot of conversation so far about nanoparticles, copper nanoparticles, and the idea of nanoparticles is obviously something that may raise questions about their applicability for use in these applications. But one thing we have to remember and point out here is that the nanoparticles that are created are in the ink. The nanoparticles go down onto the surface of the material, and then after that we electrolyse plate those materials, and therefore the nanoparticles themselves are encapsulated with fully grain structure style copper. So the nanoparticles should be encapsulated fully by plated copper after the process. I think, Andy, we can go on to the next slides, I think, from there.
Okay.
Yeah.
Shall I finish off?
Yeah, if you don't mind, yeah, that's fine.
Yeah, okay. So thanks, Neil. So basically, as we saw in the video, the catalyst has been printed at PEL. And then plating is carried out at our pilot line at Bertin-Aubert. So what you can see here is the printing of the insole and then subsequent plating, electroless plating of the insole at Bertin-Aubert. And this produced the circuitry for the insole of the footwear prototype, which we'll see later on. Okay, so that's me done. With special thanks to all these people for their help. Obviously, thanks to the whole consortium, but for this particular piece of work, thanks to these partners. Okay.
Thanks a lot. Thanks a lot to both of you for a fascinating presentation. Do we have any questions or comments about printing and plating? Gulay, Jenny, have we received any questions or comments?
Not yet, no.
Okay, well, maybe I have a question.
David has a question as well.
Oh, sorry. Yeah, David, go ahead.
What effect does sweat have on copper?
Shall I take that, or do you want to do it now?
And if you've got an answer to that, it's probably better than mine.
Well, I don't know, but I mean, we are, it certainly does, it will have an effect on the copper. There's no doubt about that. It can lead to oxidation. What we haven't talked about here, just through lack of time, is that after the copper plating, we then protect it.
Thank you.
There's a protective coating that goes on the top, and that's been with work by Alenka at University of Maribor. But as I say, due to the time limitations, we've not had a chance to talk about that today.
Okay, thank you.
Do you want to add anything, Neil? Or no?
Absolutely, that's great.
Okay.
Just recoat it.
Hello.
Carlos? Yeah.
That's a quick question. I was surprised by the studies of the bacteria you showed, and I'm wondering about the closed moth. If you studied if the closed moth, the polilla in Spanish, likes the Cooper nanoparticles.
Sorry, I didn't get the question, Carlos. Sorry.
If you've analyzed the other animals, not just the bacteria, but other animals like the closed moth.
No. As I say, this is very, very preliminary work.
Okay, yeah, but I found it very, very interesting.
Yeah, we did as well. We were hoping for that result, and we're doing more testing. We're hoping to try coronavirus on it actually, which might be relevant. I don't know why. You never know.
Any other question or comment? No. We have a longer Q&A session later on in the session. So if you have any other, burning question, keep it for then. We'll move on to the next presentation. Obviously, the main objective of the smart textiles produced as part of MATUROLIFE is to collect information about the person using the fabric. To tell us everything about that process, we have Ana Adel Lamora, who is a data scientist at ITA Innova in Zaragoza. And yeah, Ana, you have the floor, please.
Hello, everybody. Sorry for not putting the camera, but I'm having some problems with internet, so I turned it off.
Jenny, sorry, Anna, just to stop. Jenny.
Sorry, yeah, there's a slight change to the agenda, Stetsy. So it's going to be Magya now before Anna and Carlos.
Okay, perfect.
Sorry.
Okay, no worries at all. So did you say Maya?
Yeah, Maya Gokovic, yes.
Okay, right.
Yeah, hi.
And Maya, you will tell us about clothing, I think.
Yes, I will tell you a little bit about clothing. Do you see my screen? Okay, welcome everybody and greetings from Slovenia, and thank you very much for adjusting a little bit the time schedule we had some timing issues today. So basically, I will go briefly through what we have done at ISN on a closing prototype and what we have came up at the end of the project, which is of course not the end, because there are still a lot of possibility and a lot of questions and challenges, but I think that's also the nature and the good positive side of the project. So we were involved and in charge of closing development, and the process that was made was that we went from broader aspect to narrow aspect, meaning that first we started with really active communications with end users on the one side, and on the other side we have collected data about already possible solutions on market, what can be collected, which data are I don't know, can be useful and not problematic, and so on. So based on a lot of workshops we were able to do at the beginning of the project, because we were also able to have contact with end users, and based on the data collected, we have determined what are the basic characteristics of clothing prototype. It is the clothing, it's very demanding because it's something that it's variable. It has a lot of different aspects of what is useful for end user, and it has a lot of, as you will see later on, a lot of limitations and challenges within technical characteristics and what we were also able to produce. But in the basics, so the prototype at the beginning was decided to be something that is functional as well as discrete, meaning that it don't has any very elements that can bother the user, and because it is something that needs to be in contact with skin, it has all the elements have to be somehow removable or maintainable regarding the everyday use. And it also has to be independent, meaning that it can be used indoors, outdoors, within the activities, when you sleep, when you eat, when you do everything. With other partners, we have also prepared this service designed map of what should functionalities within the use provide to the end user. That was one part of the stating the inputs for the further development. And on the other side, we had a lot of design workshops, what end users actually like to wear, what are the aesthetics, what are the material desires, and likability for the clothing itself. As I said, the clothing, because it has the most wide broad of possibilities, was, I believe, also one of the most challenges, because there were a lot of limitations and challenges within textile requirements to have material that is light, that is useful, that is maintainable. Then you have the electronic part, meaning that all the components should be somehow removable, independent, not visible, not very heavy, and so on. And then there were like design requirements that were shown through the co-creations and workshops process, meaning that end users, they don't want to have something that is heavy, that has a lot of zipping, that is hard to maintain, that is hard to put on and put off. And of course, the fabric, on the one side, it has to be something that is friendly to the skin, and on the other side, it has to give us the possibility to put some functionalities, to put some electronic ones. So it was quite a challenge, and a lot of from this wider broad, when we have narrowed it slowly down to the prototype, there were a lot of research and discussions made that are maybe not shown so much in the prototype, but are very useful for any further work. So the prototype itself was developed, as I said, from different sketches, then to mock-ups, the models, and from just the basic point of view, the challenge was how to put together a shirt. We have finally decided to continue with the shirt because it is the most neutral and unisex garment of clothing. There were, within the workshops, there were also some ideas about coats and skirts or dresses, but that would be really hard to drift to the end. So we have decided to continue with the shirt as the most basic and neutral element, also for male and for the female. But also with the shirt, you have sews, you have sewing, you have pockets, you have possibility of long and short sleeves on the one side, and on the second side, you have the need to include elements for measuring that were parameters that were indicated from the end users to measure and regulate temperatures, to have possibility of cooling or heating with the garment, and to have the possibility of contact emergency called anytime, anywhere. So we have to put these elements into a shirt that is wearable, meaning that it doesn't have a lot of zippers, it doesn't have a lot of sews, it can be in contact with the skin. So with all the different mock-ups and models, we wanted to combine the possibilities of having something still light and wearable, and having something that is functional. So the sews doesn't go over wiring somehow, that the battery can be installed and put somewhere that is not visible and that doesn't bother the end users. So we switch a lot of positions, we combined a lot of cuts, and we started then slowly to putting also together the shirt. And when we have decided on the basic, most acceptable positions of the electronics, of the heating element, of the battery positions, and where the main sews go, then we have also same time started to discuss about the material. We decided to use stencil. That was at the same time put to the testing about the possibility of metallizations. And on the other side, we have recognized stencil as material that is nice to wear. That is something that can be used for a shirt, long or a short sleeve, and it's nice to wear, and it has a possibility to make male or female model of it. So somewhere at the middle of the project, we had already used stencil, but all the other electronic parts were still quite improvisoric, but already working. Then at the same time, we used the OptiText tool for different visualizations processes. We did 3D visualization just to see what is the most suitable part for battery, for electronics, for the heating element, and how does that apply to the real human body, because it has to, for the clothing, you have to really consider the size and shape of a body. That was already explained a little bit early, but I just put it just to see. So we had a workflow of a design process. We have workflow of a modeling and production process, and how to put this thing together. We were all the time thinking about end user, and at the same time we were developing also the electronic parts. So I am showing now the final bench version of the main board. On the middle of the presentation is webcam monitoring, because you need the application. And with other partners, we have also thought about having offline functionalities and online functionalities, and accesses and cloud solutions that are behind that. So that is like really in a few steps the process of three-phase development of the clothing prototype. And now I will show the video that was put together for the end user demonstrations, because of course at the end, with all the limitations, we didn't have the possibility to make real environment user testings, but we have for the all prototypes prepared demonstration videos. So I think that is the most demonstrative way of showing what was the final prototype at the end of the project. So let me know if there will be like any technical issues.
In the video, we present a smart t-shirt that can improve the quality of life of active seniors and can be used as a stand.
We can't hear the sound anymore, Maya, or I can't at least. Is that it, Maya?
So I just have additional slide just at the end to say just that we were happy to be involved in the MATUROLIFE project. It was quite a challenging, but also a very learning process. And I think the result is quite okay and we can be proud of. So, but from the Innovation Service Network, I'm sending our greetings, and as partner in MATUROLIFE projects and in some additional projects that we were also involved in, we are happy to see the possibility also for further collaboration. So that's from my side, and we have also Marian and Sasha present if there are like any questions for the ISN team. Thank you.
Thank you, Maya, and greetings to the team in Slovenia. I'm afraid we were not able to hear the sound throughout the video, but at least we were able to see the products and, you know, and get the basic information thanks to the subtitles. Any comments or question for Maya about the clothing product and the smart t-shirts? Yeah, David?
Have you tested the product in terms of putting it through an industrial washing system or a dry cleaning system?
So the tencel itself can be washed and dried with lower temperatures, but the printed elements, I think Neil can explain that a little bit more, are not so suitable for washing.
So basically what was shown in the video there were the prototypes that were manufactured at ISN. And just a little bit of context to what you saw on that video there, because maybe some of that would have been clear from the voiceover, but basically the co-design or co-creation and design activity that was taken at the early part of this project kind of indicated that the user group, focus user group, really wanted to focus on heating. So they wanted a garment with some self-heating on it. So that's the primary aim of that particular shirt garment, is the big heater on the back. The heater itself is a fabric-based heater, which is washable. The battery element, of course, the white part that is taken out, that isn't washable, but that's actually magnetically clipped into the part, so it can be easily removed and put back in with a magnetic connector. So that's easy to take in and out. So we sort of incorporated that in the usability side of things. So if you take the battery part out, then the other parts which are in there are able to be washed in principle, and we're actually going to be doing those wash tests on the real shirts, if you like, because Luxshare, the other partner who's here today, they're the manufacturers of clothing and various other things. They've made a larger number of these shirts, and those shirts, due to delays with COVID and everything else, were a bit delayed, but those shirts are now winging their way to the various test facilities, and they're going to go through industrial wash cycles at CTCR and IFTH. We will expect some challenges because of the way these parts have been put together, but in essence, they've been designed, you know, with that in mind, but not necessarily expecting it to pass on this first iteration. The other thing I wanted to point out on that video that you saw as well, we talked about, Andy mentioned at the start that, you know, having a sensor that alerts people to a fall or something with a big red button on a neck pendant was not ideal. So one of the things in the video you saw was a little fabric tab that pulls out of the shirt. That's one of the equivalents that came up through the design activities at GEDS, where, you know, some unobtrusive way of alerting an alert situation by just basically almost like removing a handkerchief from a pocket. And that's obviously, it's a little bit crude in that example there, but that's the sort of examples that came into the co-creation and the end of the clothing design. So, sorry, rather long answer to a short question.
No worries at all. Very interesting. Any other comment or question? No? We're right on time. So with your permission, we'll take a step back and sorry for the last minute change of plan in the program there. We'll go back to Anna, who will tell us about the way data is collected and analyzed by the smart textiles produced as part of MATUROLIFE. So, Anna?
Hello again, everybody. Okay, I'm going to share my screen. Tell me when you see it. 1 moment. Okay. Can you see my screen?
Yes.
Okay. So, hello, my name is Anna. I'm a data scientist in the Department of Big Data and Cognitive Systems of the Technological Institute of Aragon. And I'm going to talk about the part corresponding to the generation, processing, and modeling of the data. And at the end of the presentation, I will leave 5 minutes for possible questions that you may have. So before delving into this part, it's necessary to enter into context to better understand the objectives that will be explained later. In recent years, there have been many advances in science and technology, medicine and public health, as well as increased awareness of nutrition and personal hygiene. This translates into a considerable increase in life expectancy and consequently in a higher percentage of elderly people. This fact can be seen as one of the great successes of history, but it also has certain repercussions that must be taken into account. 1/3 of people over the age of 75 have a physical, mental, or sensory disability, and many of them end up needing care in external institutions because they don't have adequate means in their own homes. So this can often cause a feeling of dependency and loneliness, as well as a collapse of institutional care facilities. So with this in mind, a possible solution would be to provide the elderly with the necessary care in their own homes. One possibility is through smart homes to allow the user to remotely control thermostats or lights, which can be quite useful if the user in question has mobility problems or to avoid falls, for example. And another possibility is through the use of wearable technologies such as smartwatches that measure heart rate or smart clothes that measure different vital signs. Although some older people may find these garments uncomfortable, there are numerous advantages to their use. It's cheap and above all, it allows the transmission and storage of data which can be used to monitor human activity. And this is where we come in. So, what's our goal? Our goal is the generation of a smart footwear capable of detecting different gait patterns in the user and being able to notify the person in charge if one of these patterns may entail possible health risks for the user. A general diagram of how the developed system would work is shown on the screen. The gait patterns that have been considered are sitting, standing still without imbalance, unbalance, stumbling, walking, and running. These events will be explained in more detail later. Thus, the user in question would use the smart footwear worn on the right foot in their daily life. And in real time, that shoe would measure temperature, acceleration, and pressure values, which would be stored in the database. And simultaneously, the last data stored would be processed and the classification models would be applied to them, and depending on the event detected, and depending on the user, one action or another would be carried out. So, to achieve this objective, the first thing that we did was to capture to generate the data that would be used later to train and test the models. Initially, the subjects involved in the data capture were going to be elderly people, but due to the restrictions of COVID-19 that all of us know about, these people were only able to make some contributions in the design of the product. And finally, this data generation process was carried out by 2 women and a man, aged 26, 27, and 26 respectively. Okay, and which events did we consider? The 6 that I mentioned before, which are sitting, standing with imbalance, standing still without imbalance or stable, walking, running, and stumbling. And why we consider these events? Stumbling and standing with imbalance is clear that they are interesting events since in elderly people, they may be accompanied by a fall that can be dangerous to their health. And the other events are interesting depending on the user, whether they happen over a long period of time or at a certain time of the day. For example, if the subject usually walks every day first thing in the morning and is detected that he is sitting during that period, it may be a negative sign. Or if, for example, the subject is found to be standing still for a long time, it may be a sign of disorientation. So, An important factor in this data capture or generation was the introduction of certain variability, that is, the subject didn't always perform these events in the same way. For example, in the case of standing with imbalance, the subject can balance sideways, forward, and randomly. In the case of walking and running, these events were carried out at different speeds, or in the case of stumbling, the subjects put more or less pressure on the post-stumble footprint, thus having a data set as close to reality as possible. Okay, but how exactly was this process of generating data carried out? The process was as follows. The subject puts on the shoe and performs one of the events for a time. So while this event was taking place, the sensor implemented in the shoes were capturing acceleration, pressure, and temperature data with a frequency of 0.2 seconds. And this data was being stored in a database with a label that we defined, for example, first walking of subject 1. This process was carried out many times with the 3 subjects and for the 6 events. And once all the data was captured, a small processing was carried out. For example, the deletion of any frame that may have gone wrong. And after that, all the data corresponding to the same event were gathered in the same data set. So once we had a data set for each of the 6 events, we made the following division, having in mind the classification model that we will change later. So 60% would be used to train the model, that is, the model sees and learns from those data. 20% would be the validation set that would be used to select the best possible configuration of the model. And the other 20% would be the test data used to provide unbiased evaluation metrics to give a generalized value of the performance of the chosen fitted model. So before doing the training, we defined how the different models would be applied to the data set to obtain a prediction of the event. Do not forget that in the end, the events that we try to differentiate are the 6 mentioned before, color gray in the diagram, which are at the end of each of the branches of the tree. So as the screen diagram shows, an hierarchical architecture composed of binary models was considered, that is, models that classify the data into 2 possible classes. And these models would be applied following an order and starting from more general behaviors. Other characteristics of this architecture is that it's a scalable system that could grow up with more events without having to modify the initial architecture. And it's an easily modular system in which some models could be updated independently without having to modify the rest. So the operation of this architecture is as follows. The first binary model, the yellow one, is used to differentiate seated and standing. Being the first model, all the data is used to train that model. On the one hand, there is the class seated, which only contains the event sitting, and on the other hand, the class standing, which contains the other 5 events. If this model predicts standing, we will move on to the next model, color orange in the diagram, that will try to differentiate moving and still. The moving class contains the stumbling, running, and walking events, and the still class contains the unbalanced and stable events, and so on. So in the end, as we go down in the hierarchy, the events used to train the models are reduced, which translates into a greater specialization. So once we have defined the architecture and we know which models are going to be involved, what do we have to do? We have to train these models. And to train them, we have used deep learning algorithms such as artificial neural networks. And what are neural networks? They are a series of algorithms that try to recognize underlying relationship in a set of data through a process that mimics the way the human brain operates. The general structure of this neural network is shown in the upper right, where we can see that this structure is made up of 3 parts. The input layer, the first part, which the values of the variables measured by the sensor enter, mean the acceleration, pressure, and temperature. Then the hidden layers, where the transformation of the input data and perform, and the output layer composed in our case by 2 nodes, since the models are binary, for example, to differentiate running and walking. In addition, regarding the hidden layers, they can be of various types, such as dense, convolutional, long short-term memory, and each of them is specialized in detecting some patterns or others. For example, the convolutional is used to extract relevant features, or the LSTM is used to find correlations along the time. This with respect to the type of hidden layer. But what about how many hidden layers can there be and how many neurons for each layer? Instead of defining a specific value, what we did was perform an automatic search for the best hyperparameters in each of the cases. Some of the possible parameters of the neural network that could be optimized are those that appear in the table below. For example, the number of hidden layers, the number of neurons in each layer, or the use or not of a convolutional layer. Another important aspect was that the model was also allowed to select or not each one of the 20 values measured by the different sensors. So in the end, what we did was store the best models, each of which use different sensors as input, so that if any of the sensor fails, the second best model that doesn't use that sensor can be applied, and therefore maintain the system always alive. So after conducting a search for the best hyperparameters in model training, we found that the best configuration for each case are the ones that appear on the screen. It can be clearly seen that the model that detects stumbling and the one that detects imbalance are the most complex of all, since they use 11 hidden layers and a convolutional layer to detect the specific features, while the others are simpler models that use between 1 and 3 hidden layers only, and they don't use the convolutional layer. And what could be due to this complexity of these two cases? One of the reasons is that these events are more difficult to detect, or there is greater heterogeneity in them. There are more differences in the way of stumbling or balancing between two different subjects, or even in the same subject, and the model needs to be more complex to detect patterns in these events. This difficulty in detecting these events is also reflected in the metrics obtained in the test set. The metric shown is called accuracy, and it represents the number of correct predictions with respect to the total, this maximum value being 1 in the case in which all predictions are correct. Although in general the models have a very good discriminatory capacity with an accuracy very close to 1 in 3 of the cases, the unbalanced model, and especially the stumbling model, have a lower accuracy, still being quite high. Even so, if we apply the models following the hierarchical architecture that I mentioned before, we see that the global accuracy is quite high, of 0.84, which indicates a remarkable performance of the model. Now we are going to see a video about how these models would be applied in real time with 2 different subjects.
Is there sound in the video?
No. I'm going to comment a little bit. In the background screen, the predictions appear when applying these models hierarchically. In this case, the user starts from sitting, then stand up. We see that the screen is updated and saw the prediction standing. And finally, see unbalanced sideways, as we can see. And on the screen, the prediction is also updated to unbalanced. In the second case, the user starts standing, then starts to walk, and finally stumbles. And the predictions are also updated correctly on the screen. First standing, now walking, and finally, as we will see in a few seconds, the label stumble will appear. And finally, in this third case, the user starts walking and then she stumbles, and the predictions are also updated correctly on the screen. Now walking and now stumble. So, as general conclusions, what do we finally have? Well, we have a system capable of detecting gait patterns with high accuracy, an easily modular system, since each of the 5 models mentioned can be created or updated independently. It's also a scalable system in which more events could be added, a live system that can work even if some sensors fail, and a system in which the possible alerts can be customized depending on the user. Thus, through this system, we provide an effective solution so that elderly people can age with the highest possible quality of life and independence in a non-invasive, comfortable, and economical way. Thank you very much for your attention, and if you have any questions, you can ask me now. Also, Carlos can answer you, depending on the question.
Thank you, Anna, and thanks for sticking to time. Any question or comment? Yes, Andy?
Hello, thank you. Thanks, Anna, for that. Could you just confirm, are you just monitoring 1 foot or both feet?
1 feet, 1 feet.
And does it matter whether that's left or right?
It's the right feet.
Okay, thank you.
Thank you. Any other question? Yes, David?
Can the shoe take my temperature?
Sorry?
Can the shoe take my body temperature?
Yeah, I mean, is the temperature of the, yes, of the, well, maybe Carlos will explain this question better than me. I'm more with the processing and the modeling of the data. So Carlos, if you can answer this question.
Okay, hello, David.
Hello.
Actually, we've worked, the work shown by Anna has been done with the 4 network prototypes that have been developed by CTCR. And the PCB, the electronics included, if I'm not wrong, accelerometers and the sensors using the smart textiles of the MATUROLIFE project. And I would say that it included the temperature, but actually the temperature sensor. But actually, Javier Cortés from CTCR could confirm that point. But for the predictions we've done, we haven't considered that sensor. Javier, could you help me?
Hello, David. Hello, Carlos, Anna, all of you. As Carlos said, the sensors include accelerometer and other different parts, and also a temperature, but temperature is not focused on the body temperature of the people. It's focused as a parameter to control the correct behavior of the sensor and all the electronic part, not focused on the people.
Thank you.
Thank you.
Do you need specific shoes, or is it for any kind of shoes to wear this sensor?
Yeah, one of the partners of the project is Pitillos, that is a footwear manufacturer of Spain, of our region, La Rioja, in the north of Spain. So they have developed the prototypes, the footwear prototypes, the shoe. And the sensors have been specifically adapted to this kind of suit that, as I say later during my presentation, you can see of all these details. But yeah, these sensors are have been developed specifically to the shape and to this design, a specific design for the shoe. Okay, but this is not exceptionally. This could be used for another different, the technology could be used for another different shoe. The only thing that we have to do will be to develop a new design of the sensor that will be in accordance with the new design of the shoe. Okay.
Sure.
Is replicable.
Thank you, Javier. Any other comment or question? No? If not, well, this is the perfect cliffhanger, you know, with a teaser about the footwear, because we'll hear more details about that after the break. I'd like to suggest a short break for now, 20 minutes. Is that okay? So if we can all be back. Yeah, Gulay?
We ask everyone to be online.
Yes, I was going to say, please don't disconnect to prevent any technical issues. So maybe turn your camera off and your microphone, and let's all be back at 11:20, please. Thank you. From Itainova, and Carlos will tell us everything about the furniture produced as part of MATUROLIFE.
Hello. Good morning. Yes, as has been said, I'm going to introduce you about the furniture prototype and the works done for the furniture. My name is Carlos Gonzalez. I'm software engineer at the E-Innova Institute of Technology. E-Innova is a non-profit center with the mission of supporting mainly the Aragon region in Spain to introduce the new technologies, new research and innovation in their business processes. Okay, and in the context of the MATUROLIFE project, E-Innova role has been to lead the Work Package 6, the integration and production of the prototypes, with the coordination and specifically for the furniture prototype, for the sensor integration of the different sensors, and is also responsible of the whole software infrastructure for mainly for the data acquisition and the management, to use the E-Innova expertise in big data analysis to provide added value in early pattern detection, as my colleague Anadel has already explained to you. Also, E-Innova has a semi-anechoical camera for perform electromagnetic compatibility test and electrical safety testing that ensure that the devices are safe in extreme conditions, as well as in daily use conditions. The furniture prototype. The furniture prototype has been the product of the cooperation of 20 different organizations and small companies, small and medium companies, with expertise in different areas. We've had, as you've seen with Andrew Neil, research and companies with expertise in electrochemistry and nanomaterials to produce smart textiles, with fashion and design companies to produce fashionable products that reduce the rejection of the assistive technologies. Lots of projects have failed because the final users of the products have rejected them because they supposed discrimination for them, because these products were not normal or were not fashionable. And also, the project has involved the caretakers and our elders, our adults, involving them in the process life cycle from the early steps, as we are going to see. And also, organization focused on the life cycle management that boosts reusability and embrace the paradigm of circular economy. And finally, we also had industrial partners to produce these prototypes. Okay, the first step took place in early 2018, where a wide variety of users was involved to come with their idea, their opinions, from different cultures, mainly from Europe, but also from different parts of the world. And a process that involved different techniques were applied for co-create and for collaborate, that led to the idea, to the features that are in this case, the furniture prototype should offer to the potential users. Down, you see the priorities and the requirements for the three prototypes, but for the assistive furniture was to enable improved sleep and mobility. Besides that, other functionalities have been summarized in what is called the service blueprint that offers the understanding of all the different elements and features that the software should offer to the potential clients. This image is very important along the whole project because it is the cornerstone that will lead the rest of the development. These previous works of co-creation led to different mock-ups and 3D designs that through an iterative process led to the early stage prototypes. And after that, after analyzing these prototypes, a second round of conversations between the team members had led to a final prototype that is an up-to-date design with the small features that you've already seen, that integrates the sensors and the smart materials that you already seen. Okay. Also, the user interface behind every device nowadays, there's a piece of technology. In this case, you have the user interface, some mockups, not mockups, these are the real ones, images that show the behavior of the product with different features that offer the user interface. And also down in the bottom part, you see a third-party application that is Telegram. That is the selected application that we use for communicating with the relatives and the caretakers that are in charge of the health of the users. Behind the prototype, there is a piece of software that is the backend. The backend is the final destination of all the collected information, and also a more in detail view of the backend shows all the steps that the information has to take for being analyzed. Here you see in the blue head on the right side the process that Anadel has already explained. So all this infrastructure, software infrastructure, is needed for doing this kind of utilities. We also offer a stable architecture that is able to support a growing number of users in the system using the Kubernetes infrastructure, and also offers availability because it detects when any of these components fails for restarting and ensuring that all these pieces of software are available at any time. Also, this infrastructure is transversal because it accepts information from different, in this case, different devices. You see in the image the footwear prototype devices that send information to us, and also a growing number in the future of potential devices. Now I'm going to show several videos showcasing some of the blueprint use cases. In this case, let's see. In this moment, just one quick question. Do you listen to the audio?
No.
No.
I was going to ask. Yeah.
Okay, yes, it's important because every presenter is failing on that. Well, just one quick message. In this case, the user, I'll present the video myself. The user has put the sofa in a relaxing position, and now the system is going to analyze the breath behavior of the user, the position and the breath behavior, to detect that the user is in a sleep mode. So the time of the sleep is starting now. As I said. So there is a message in the system waking up the user. And now the sofa is supporting the user, helping him in standing up, moving the whole sofa to place the sofa in this position that you see. That is one of the user demanded features. In this second video, you can read the message. In this case, the user has the panic button on hand. In the behavior is similar to the one in the cloud. The user activates the button, and in the background, the relatives are warned. There is a conversation between the sofa and the user. In this case, you see there is a pop-up message on this. Represents the mobile of the user. Okay, informing of the event and asking for confirmation. And in this third scenario, there is in this third scenario, the user interface shows the activities performed by the user. That way, relatives can have a view of the environment of the home. So the concluding remarks is that the cooperation of all the different teams have been very important to produce the 3 prototypes. And that looking at the same problem, this is a personal reflection, looking at the same problem from different points of view and builds otherwise unseen solutions. I'm from a technical point of view. I wouldn't have think of solutions that provide some of my colleagues. And the roadmap is just the beginning. It is not the end of the project, because there are a lot of opportunities. Extending the use of smart textiles in a wider range of devices, applying the incipient data analysis knowledge we have to expand the number of behaviors detected. And with the main core, the main focus of easing in a non-intrusive way our adults' independence, and also contributing to the circular economy, producing cost-effective products. Finally, I would like to thank you for your interest and all the consortium members that provide me with support, technology support, personal and professional. for this project. And also to my colleagues at ITA Innova. Thank you very much. And now any question is welcome.
Thank you, Carlos. I have a quick question. I think you mentioned it, but just to make sure, the sofa cover is entirely washable. Is that right?
Actually, yes, it's entirely washable, but beside that, there is another video, but that will be too much time for the videos. But beside of that, the cloth used by Mueble Comfort is one of these kind of clothes that is washable on the spot. So if you drop some coffee or some dust on it, you can take a white cloth and clean over it.
Thank you. Any question about the furniture, the sofa? Yes, Catherine?
Yes, I would like to ask something about the target of circular economy, of course. And did you use, for example, recycled textile, or what do you mean when you say that?
Okay, recycling the circular economy is mainly embraced by the material used for the smart textiles. Okay, and also for the works done in regarding the life after the life of the product.
Yes, I know.
Yes, studying partners have specialized in studying how these products will be reused and recycled.
Thank you. Very interesting to put this aspect in your research.
Mm-hmm. Mainly, I have to admit that it has been the work of Coventry University and Pell and all the members researching in the Cooper nanoparticles.
Thank you. I agree. I think it is indeed a very interesting and important aspect that we should promote in the future. Additional questions, comments?
Like?
Yes, Gulay.
Thank you. It's a very promising product. I was wondering if you received any feedback. Did you try it with your target users? Did you get any feedback from the usage of it? For example, that the interaction with the product. For example, the panic button. What happens?
Yes.
What happens? I accidentally push it, etc.
That is a very interesting point. As you've seen from my presentation, I said at the very beginning that we try to involve the wider variety of users from the very beginning. But sadly, due to the COVID-19 restrictions, we've been fighting, hoping to ease those restrictions, but in Spain, have been till recent weeks, we've been under very tight restriction, and it has not been possible to do exactly that you are asking for. Beside of that, if you've seen, my colleague Anna has shown the data extracted from 3 people, but the initial target of the project was a wider variety of users. So we've haven't succeeded. Also, we've performed some testing on users that Denise could help on us. Yes, because she has led the work package or Javier Cortez regarding the user interface, but it had to be a remote testing, not a real one, but a remote one with different videos collecting their feedback. Of course, the iteration would have been much better if we had their direct use.
Yeah, Louise, or are you there, Louise? Or Daniel? I don't know if you just want to make a quick comment about the user testing.
Mm-hmm.
Yeah, sure. So the user testing, originally, we hoped to be able to provide prototypes to people to potentially take home and use at home and give feedback. The way we've adapted to the current context is to create videos of those prototypes and then show them in an online environment. So Daniel, who's also on the call, has been running the testing sessions, and we've been inviting people to come along, look at each of the prototypes separately. They've been run as separate sessions, but we have now had about 15 people looking individually at the clothing, the footwear and the furniture to give their feedback. So they've had a bit of a demonstration of how it works, and been able to give us direction on how they could be improved and further developed.
Thank you.
Thank you.
Any last question? Yeah, David and Laura.
I would like a receptacle in the arm of the product so I can put my can of beer in it.
So thank you, Carlos, for the very interesting presentation. I was wondering, you said that the users could look at the data, but if I'm an older person having a lot of impairments and have difficulty getting up, that's one of my questions. It makes you more or less dependent, to get up.
No.
There could be other ways to keep your autonomy by, well, the more traditional ways like exercises, etc. But nevertheless, it can help to get up. But then the data, which would the user be interested in the data?
Okay.
I'm saying this because I'm wearing a Fitbit watch and walk and try to stay active. I get quite irritated because Fitbit gives me sort of assignment to make an update, etc. So how is this older person? Will she look at the data at all, or
okay,
you have to arrange updates all the time?
Yes, I'm aware of the boredom of the data because my mother is with her smartphone, and the smartphone is bothering her every day, saying you haven't walked too much, so you need to exercise more. I understand you very well. No, what I mean about the technology in the project is, first of all, there is a configuration that we always count of the relatives or the caretakers for helping people in that. Actually, Muebles Comfort in Aragon, that is the producer of the furniture, when they take the sofa to their homes, they always have, their professionals have a process of explaining how the sofa works. Imagine a simple sofa that only has an engine for moving, or explaining the protocol for cleaning the clothes. In this case, the professional would explain how to do the initial setup of the product. That is true that you need to be near the technology for doing that. So imagine a relative. In my case, I set up the technology for my mother. So once the technology is set up, the user don't need to do anything in a daily routine. They don't have to do anything. Okay, so regarding the sleep time, there is one setting is how much time does the user sleep. So the alarm warns the user after that time, but the user doesn't have to do anything about the data, because the data is automatically collected and is sent to the backend. I've explained. Okay, and this backend is analyzing the data, but the user doesn't have to do anything. Other thing is the kind of messages that you say about keeping active and that sort of things. In the case of the video, you've seen that there is one message when the user wakes up. There is one message with the panic button, and in the event of an abnormal breath detection pattern, okay, that would be a different kind of message, but mainly focused on the person that is supporting the users. That is the relatives or the caretakers. So do not worry, because this what we have in mind is not bothering the user every 5 minutes, reminding them to keep active. Only I think my colleague Anna talk about that. Only if long periods of time in the same position would force a message. Imagine that you have been for several hours in the same position. Maybe in that scenario, the message is spoken to the user. But we try to be the less intrusive as possible. Yes, David?
Thank you, Carlos. Yeah, David, brief comment or question, please.
Yes, we are behind the shadow.
The product actually could be very useful for what's now being called contactless medicine. So it will collect data about the individual, feed it to a physician, for example, or a nurse, and that data could in fact be used to medically manage the patient. Mm-hmm. Furthermore, the data put into a big data system could help in what's called predictive medicine, so that we can predict various things about what is going to happen to the individual. So, for example, are they going to have a heart attack anytime soon? Or on a macro level, you can take all this data and look at the herd and predict medical needs in population. So there's quite a big range of applications for this particular type of technology. Thank you.
Mm-hmm.
Just to comment on that, David, I think that's a really good point, and you're definitely right about that. And when we initially scoped out the prototypes at the beginning of the project, we were very much trying to think about who those sort of secondary users might be, whether they be clinicians or care facilities, with the thought that in the long term, then yes, we would be collecting a raft of data that could be really useful. The shoes in particular are an example where we're collecting data that we would like to be able to use predictively to see where those problems are in the future. But ideally, all three products would work together as a package, collecting that data to then inform how we might predict difficulties and proactively put preventative measures in place for people.
Mm-hmm. Just one quick comment. Supporting your idea, David, different devices in the platform, as I spoke before, could provide more information, and the more information the data scientists, like my colleague Anna, have, the more prediction they can have. Also, it's also important to to involve the professional, the doctors, that know the subtle difference and helping and work together to extract the more information, the behavior, and the diseases as you spot before as possible.
Thank you, Carlos. And everyone, very important points there. We'll have more time to discuss them, I think, during your or following your intervention, David, and during the last Q&A session of the event. But for now, we're running late, so I'd like to move on to the third and last product. No worries at all, which is the footwear. So Javier, if you don't mind, I'd like to give you the floor. Javier Cortés Cameros from CTCR in La Rioja, and you will present the footwear.
Thank you very much, Stacy. So thank you for all you to attending this event, and especially to the partners of the project, to all this emotional and fantastic project that we have developed during the last 3 years. So I try to share my screen. Okay, so are you able to see my screen, not? Okay.
Yes.
So this is the last of the 3 prototypes that you have seen today, the clothing, furniture, and this is the last one, the footwear prototype. So during the first part of the project, approximately 1 year, we have developed the concept of the footwear prototype that we want to develop for the elderly people. So finally, the focus was to find and balance. So the idea is that elderly people have a product, a suit that helps in their daily life. So as you can see, for example, in these 2 phrases, is that they are able to prevent this possibility of falling, so the risk of any balance. So with a suit that would be similar, the same as any other one that you can see in the market, in terms of comfortable, in terms of fashion, in terms of adjustable, flexible, and so on. So to focus on this risk of falling and changing the balance, we use and we have developed in a project different pressure sensors that are focused in the insole of the footwear, in the insole of the shoe. We are only focused on the right shoe, not in both left and right, because as we know, our background in different previous projects, if there is not any other problem of the people, the behavior of both is very, very similar. So also for that, we focus only on one, in this case on right foot, but we can use the same in the left. And we focus also with select and design the materials that we want to use for this footwear prototype. We use typical footwear products, footwear materials, also for upper insole and for sole, and in combination with different other complementary materials to increase the functionality of the final product. We use also light material to have a light suit. Not we want to obtain a weight suit because we focus on these elderly people. After this part of design during the first year of the project, that also we are mainly in contact permanently with the elderly people through interviews, workshops in 9 different countries. Okay, we obtained this sketch concept. This is for women. Okay, and you can see in this image the initial idea of the product, and also where is located the sensor, the PCB, and all related with that. And that's the chain for the MEM. Okay, this is the initial idea, and as I said, the idea is to integrate this sensor on the footwear in between the insole and the sole, but for the people that use this footwear product, the similar is the same that's another product because they are not able to see or to manipulate the sensor, they are protected. We have all the guarantee to guarantee this security for the user. So also in collaboration with the design partners, especially with guys, thank you, Gulai, we develop during the project, and we optimize each day by day this service design service blueprint map of the user of this footwear prototype. We want to have a strong setup to guarantee the use of during the daily use of the products, and to send the different alerts, emergencies when falling, so to prevent the balance of the people that use. Also, we develop easily maintenance of the product. It's typical of another footwear that not contains the technology, so this is very, very good for the final user of the product that we develop. So here we have the two different men and women final prototypes that we have developed. As you can see, it's very similar in terms of design of the initial optimized designs products that we accord in parallel with the interviews and workshops with the elderly people. And as you can see, it's a typical footwear, both in both cases. And the only different thing is that they are integrated the sensor developed in the project. Was the sensor, here you can see two different sensors that we have used in the project. We in parallel and in collaboration, thank you with Pearl, with Neil, and also with Sensing Test, with Luis, thank you for both colleagues. So with these process sensors, we are able to control all the parameters that we want to the focus of risk of falling unbalance. Okay, we are able to control the different parameters to collect this information in an application. We have also developed an application. You have an image of this application, and we are able to send all this information to Itainova, to the group of Carlos, to analyze all this information and to obtain the parameters and all the data necessary to prevent the focus of this objective that I mentioned before. Okay, so this scenario that we have for this product, that I said, is to helping me to feel safe also at home and out of home. So when going upstairs, when going walking. So for that, the initial idea after that was changed due to coronavirus was to use two different modes of use. So for that, as I said, we collect all the information that we obtain with this sensor, and we send that via the application that we have developed in CTCR to the Itainova. So at this moment, I try to share a video that is, one moment. Okay. So with this very short video, only 5 minutes, we are able to show all that I mentioned in the presentation, okay? The objective is to develop this smart assistive footwear. Here you can see the main footwear prototype that we have developed in the project. So you can see the insole, the typical insole that contains, this is from Pitillos, the partner of the project. And between the insole and the sole, you can see at this moment the sensors, okay? This is the insole, the pressure sensors that are located in this part of the shoe. And as you can see, the appearance is very, very similar to any other footwear. So to start with the use of the footwear sector is necessary, or footwear prototype is necessary to create an account in the application that I showed you before. So with the typical information, the name, female, male, the year, and some related data. This is necessary to connect the sensor and the footwear to the application. And at this moment that we connect to the application, we are able to collect all the data that we obtain with the pressure sensors that are in the footwear, okay? So that's important after that to send information via this application to Itainova to the analysis of the data collected. So at this moment, as you can see, via Bluetooth, we connected and the footwear are connected with the application and with the big data platform. This is a small demo of the use. Okay, as you can see, it's very, very easy to put these shoes also in terms of men and women. Okay, this is very good for the people that are focus this product, elderly people. So you can see also in the right part of the video, the image of the different pressure sensors that are located in this insole that you have seen before, okay? So this is in real time. And after that, this information is sent via this application to Itainova. With this in the application also, you have another information about some report reviews and recommendation that could be useful for the people, for the end user people. And also, as I mentioned, all this information is sent to Itainova and they analyze, they can search some errors in terms of risk of falling on prevent my balance to the user at real time. The last part is maintenance of these products. You can see this, the only electronic part is the sensor that is connected to the battery. Okay, so it's very easy to remove it. And if it's necessary to substitute this battery that is located in the last part of the SO. Okay, you connect as any typical mobile phone and it's charging at this moment. And when they finish the charging, we are able to locate it again in the same position. So as you can see, it's very, very easy for people to do this maintenance. Okay, it's also important to mention that after this development of the footwear prototypes men and women, we have also carried out different electronic, physical, mechanical, and chemical tests to guarantee that the product is able to put in the market with the legislation and in accordance to the conditions that European partners, European countries are mandatory. So for that is really, really good. The physical test, the mechanical, all are in agreement and are very similar to another typical footwear. So to conclude, we are able to develop in this project a new product that are able to recollect information at real time for these elderly people and to analyze by the big data platform of Itainova to obtain some patterns that would be okay or would be good for the end users to increase their daily life and to have very good information to prevent all related with this day. Okay, so that's all for my part. So that's open for any question or that you have. Thanks.
Thank you, Javier. Any question about the footwear?
Yes, I have a question, Javier. Hello. My question is quite simple. Is this sole watertight if you walk under the rain or walk in water puddles? What happens with the electronics?
Okay, thank you. That's a good question. All the electronic part, the sensor and also the battery is protected between the insole and the sole. It's not possible to have any diffusion of water or something like that during raining or something like that. For that, as I said, during the physical and mechanical tests, we have developed a specific test for that. In this test, we introduce the footwear in a cube of water, and we analyze if it's able or not to diffuse this water through the sole or through the other different materials to the sensor and to the battery. So the results are very, very good, and that's not possible. So guarantee the protection of the electronic part, and it's also important that these electronic parts are protected to prevent any problem with the end user. So for both different points. So during the test that we have carried out in CTCR and IFTH, we are able to guarantee this point.
Okay, gracias, Javier.
Gracias.
Javier, it's Barbara here from the Manchester Fashion Institute.
Hello,
have you thought of, I love the idea of the shoe, but have you thought about actually just being able to do the insole so that the people could put it in their different shoes, because they'll be in a soft shoe? A lot of these people have swollen feet, and women wear more than one pair of shoes. I can tell you, we love lots. So
we have developed the same sensor in different size, depends of it's woman or man. We have developed in terms of women a range between 35 from 35 to 20 to 41, and in terms of men from 39 to 45. The initial idea, if coronavirus doesn't have, was to carry out the testing with elderly people. So for that was necessary to develop footwear prototypes and footwear sensors in this wide range of sizes for guarantee the testing of any different people depending of this footwear size.
Okay, thanks.
Thank you. I guess there's another additional constraint attached to that, Barbara, which is the battery.
Yeah, that's what I was going to say. You really need a shoe that's got the been adapted to take the battery.
Yeah, as you can see, this battery has enough life, approximately 1 week. 1 week intense use, okay, all day. So, and after that, as you can see in the video, it's very easy to produce and to have this maintenance, and the charging it's approximately 3 hours. Okay, so for example, you can do this charging during the night during you are sleeping. So after that, when you wake up, you have your footwear so again able to use during 1 week.
We also considered wireless charging as well, so that you don't
Yeah.
have to take that out.
Yeah, we studied this part also in the project.
Hello, Javier. It's Daryl Fox here. I'm just thinking every footprint is different. Everyone's individual footprint is different. Does that affect the positioning of the sensors, or does it affect the long-term performance of the materials?
The position of the sensor was studied, and as you can see in the image, they are located in the main parts of pressure of the feet. Okay, that's the reason for main points are located in the sorry, in the fingers. Okay, in this part more or less, and the other one in the opposite part.
Thank you. Any additional comments or questions? No? Okay, in that case, we're pretty much on time, or perfectly on time, actually. We've heard everything about the activities carried out as part of the project, so from the project partners, and it's time to open the floor and hear the perspective of external partners. And to kick off the discussion, I'd like to give the floor to Andy Cripps, who is the Senior Design Manager at the Design Age Institute in the UK. And the Design Age Institute has been created to help the UK government address the challenges posed by aging through design. So Andy, the floor is yours, please.
Hello, thank you very much. Let me see if I can share my screen and my presentation. Can you see that? Is that working? Great,
yes.
Thank you very much.
Yeah.
So thanks for the intro, and thank you very much for the opportunity to just spend a couple of minutes this morning to introduce the activities of the Design Age Institute. We're part of the Helen Hamlin Centre at the Royal College of Art in London. Helen Hamlin Centre has been around for about 30 years, addressing all sorts of problems within the economy by the use of inclusive design, and I'll talk a little bit about that as I go through. So we are recently formed at the Design Age Institute. We are aiming to become the national strategic unit for design and the healthy aging economy. We're part of a 5-partner consortium with the Oxford Institute of Population Aging, the National Innovation Centre for Aging, the International Longevity Centre, and the Design Museum, all of course within the UK. And as I said, we're part of the Helen Hamlin Centre at the Royal College. If you don't know, the Royal College is a 180-year-old postgraduate university in London, specialising in art and design. Oh, my buttons aren't working for some reason. So this has been mentioned a couple of times this morning, but I like to share this slide because it never ceases to shock me. For the best part of 10,000 years, the human race's life expectancy from birth has been somewhere in the mid-20s. In the last 200 years, that has shot up to become the mid-70s. And of course, that gives us lots of opportunities, but also it does potentially provide some issues. The opportunities, certainly commercially, are quite profound, I think. These figures, I'm sure you'll all be familiar with because they're echoing what other speakers have said. Within 20 years, within the UK, 30 million people will be over 60, and the over 55s will be accounting for sort of 63% of the wealth being spent, which is something that, if you just stop and think for a moment, is a massive potential. And of course, technology proliferation, particularly accelerated in the last 14 months by the lockdown, is being predicted to be virtually 100% within the next 10 years. Inclusive design may be something that you've not heard of before. I'll leave that little definition from the British Standards Institute there for you to read through. And a photograph of perhaps one of the most well-known exemplars of what inclusive design means. These are the Good Grips series of products that were initially developed from an insight to help an arthritic grip problem, but have since become something that have a huge range of activities and potential, which sort of demonstrates the principle of inclusive design. If we think about the market that we can all address as manufacturers and producers, if we concentrate on the less able and solve a problem for them, it actually means that we can address the whole market, because whilst it solves a specific problem, it makes it easier for everybody to use, which is, the Good Grips are a great example of that. So at the Design Age Institute, we are trying to help other folk develop products and services that lessen the impacts of the consequences of aging, meet user needs and wants, and most importantly, their desires. And to do that, we have a number of Pathfinder projects, which we're categorizing into 5 areas. Forgive me for sort of flipping through this, as I only have a couple of minutes, but I'll give you the website details later to catch up. So we're looking at 5 areas here for increasing the potential of folk as they age, and therefore developing products and services to help. So in ability, in independence, in work, and home. And of course, those two have become much more connected in the last year because of the lockdown. I mean, we're all on this conference this morning, from home or working remotely. So that's, we've had a fundamental shift in the last 14 months. And of course, most importantly, connections about people and tackling social isolation. So we want to help folks with ideas and with prototypes to collaborate on projects and to move design-based projects towards market. We do have a great research base at the RCA. We can tap into the good body of work in other academic institutions within the UK, but we want to bring products to market. So we can help that by some seed funding and some expertise that we can bring in, both from ourselves within the team and through the wider networks that we work in, to look at scoping opportunities and mentoring individuals and entrepreneurs with those opportunities through to market, using specialist designers, which we know and we're building a directory of, to actually take that work and make good technology and good ideas into good products. We can access user groups and research, as I've mentioned, and obviously when the time is right, we have a great platform for dissemination through our partner at the Design Museum in West London. Really, I think what our kind of guiding thing for you to take away this morning is that we want these products to become products of aspiration and not desperation. We want them to be meaningful and beneficial to the users, but actually things that, like our computers, like our clothes or our specs or cars, products around the house, furniture, they're things we choose to buy or would choose to buy based on their look, their aesthetic, their feel, the way they make us feel. So that's a very, very brief whistle-stop tour into the Design Age Institute. I hope some of that has at least made sense. I'd be delighted to talk to you. Here's our contact details, the website, all the W's, designage.org, and our email, which is somewhat of a mouthful to say, dai-hhcd@rca.ac.uk, but there is an easy click button on the website. So thank you once again for the opportunity to present, and I'd be delighted to hear from you either later in the questions or via any of the electronic means. Thank you.
Thank you. Indeed, does make sense, and it's extremely interesting. I'm wondering, do you have any counterparts in other parts of Europe or the world, or is it British?
That's a very good question. I'm afraid I can't answer that. I'll have to come back to you on it. Certainly, we think we're unique within the UK. I mean, we are funded by Research England in the UK, but it's certainly addressing issues that are common to every country and every population. So whilst I can't name names at the moment, I would be surprised if it's only in the UK.
Well, certainly very timely and relevant. Thanks a million for being with us this morning.
My pleasure. Thank you.
Sorry, for some reason I muted myself. So there's no good party without a French touch. So now I'd like to give the floor to Pascal Negret from IPM2. Is that the way you pronounce it, Pascal?
Well, it depends if you say it in French, IPM2, or in English.
Okay, IPM2 then.
IPM square.
Okay, right, sorry. And if I'm not mistaken, you have interviewed a representative of the University of Technology in Troyes for us, is that right?
Yes, that's right. Actually, it is thanks to Catherine Marcadier-Sarflix, who made this opening speech earlier today. I met her as an SRP representative, and she contacted me later, and actually this year, to put me in touch with a French senator who was responsible for an area in France called the Department of Aube, and the main town there is Troyes. And in Troyes there is this university, and actually this contact was quite interesting and quite relevant, because the University of Troyes, as you will see in my little video, is definitely addressing issues and topics which are similar to those which we've been working on during the 3 years of MATUROLIFE. So I will show you this video. It's an interview and also a presentation of what happens there in this university, this technological university of Troyes. And you will see that there are many contact points between us in MATUROLIFE and them at the UTT, where they are dedicated to what they call a living lab, which is an initiative that they've been experiencing for many years, and where they have done some very interesting applications that I'll try to show you in this video. So I will share my screen. If I can. No, that's not. No, that's not it.
Can you see the share screen button on the right side of the chat at the bottom of the screen?
Yes, yes.
So if you click on that, you should be able to see then your different windows in the video, if it's
Yes.
open.
Yes, I have it on another screen, that's why.
So Pascal, if you want, I can share it for you.
Yeah, I can share it for you if you want, if it is just a video.
Well, I hope you'll have a good sound.
We can try. This is 13 minutes. Let me open the voice.
That's it.
Good morning. This is Pascal Negret from IPM2. Today we are 200 kilometers away from Paris, where are our premises for the MATUROLIFE project and the Paris partners. And we are going to the University of Troyes, the Technology University of Troyes, where we are going to visit the special premises dedicated to the Living Lab. So we are going to meet Thibaut Vigier, who is the director of the foundation of the University of Troyes, and he's going to explain us the reasons why we are here and what are the contact points between the MATUROLIFE project and his university and his goals. So we're going now to meet him at the main entrance of the UTT here in Troyes. Hello, Thibaut. Welcome. How are you? Welcome to the UTT. Yes, thank you. Thank you. We are very happy to be here in Troyes today with the sun. So you're going to explain us why we are here and what you are doing in this university? Yes, of course, please. Okay, let's go inside. Okay. Well, Thibaut, thank you very much for welcoming us here in Troyes. Well, we have the map because we are still living in restrictions. But explain me why the University of Technology of Troyes has now become part of the European University of Technology.
Yes, thank you, Pascal. Of course, we are now a European University of Technology thanks to the European Commission. We are a European University of Technology called EUT+. We have 7 partners with us in this project. Dublin in Ireland, Cluj in Romania, Sofia in Bulgaria, Limassol in Cyprus, Cartagena in Spain, Darmstadt in Germany, and Riga in Latvia. The UTT Foundation that you see here is a support of this project. Our goal is to raise funds for our students and the research, of course. Speaking of research, one of the major themes at the UTT is silver technology. And that's why we are building this project together, this project called MATUROLIFE. We are very proud to be part of this project, thanks to Pascal, to support MATUROLIFE, and I hope that we can help you for this realization today. Okay, well, thank you very much, Thibaut. It's true that thanks to Catherine Marcadier, who made the contact between us, the MATUROLIFE project, and the University of Troyes, the role of Catherine being the stakeholder panel representation. This has enabled us to be aware that
somewhere else within the European project, also dealing with the silver economy, and is also dealing with these concerns with this topic. And you will see later during the visit that the University of Troyes has a very special organization, very special premises dedicated to the silver economy. So we are going to be visiting later with Thibault and his colleague. Okay, so let's go for the next stage. Okay, and next visit. Carry on.
Sorry for the bad sound with the masks.
With this very special room dedicated to the visualization of the different applications that can be set up and assessed here within the Living Lab organization. And Dimitri, our host here today, will explain us two specific applications, one with this robot and the other one with the special connected floor. Okay, thank you, Dimitri. What you explained us is that this robot is one example of a tool which is dedicated to the preparation of different applications for special places like retirement houses or care houses, where the people will need some help in their daily life because they are elderly people. And with this tool, we can make experimentation and refine the applications that can be done in these special premises where the older people are living. So this can be helpful. Of course, there are many tools that can be integrated in this robot, and the role here in this special visualization room is to find the best one and to refine them in order to be efficient when it will be in the care houses. Oh, hello, Thiago. My name is Pascal. Thank you very much. Oh, yes, thank you. See you next time also. Have a good day. Thank you, Thiago. Goodbye. Another example is this connected floor. This floor is connected, and the way I'm walking is recorded with all the cameras that you can see up here above me in this room. And this will be able to visualize how I'm walking, what are the difficulties, and this connected floor has been designed for that. So it's another example of an application within the Living Lab. And we'll go now to the one of the model apartments made for the more refined visualization of these tools. And you will see that it can be integrated in a real apartment with real furniture in order to have people living there and benefiting of these special applications. So now we are entering one of the model apartments, which has been dedicated to the experimentation of some of the applications developed here within the Living Lab. It's a small apartment, not exactly decorated the way you would, but it's efficient. Here we have, and Dimitri is showing us in this bathroom, a connected scale, which will be used for more than knowing how much you weigh, and also a connected mirror, which will give you some information. It's still a mirror, but you have the temperature, the news information, some radio, and of course, what time is it? Another example is this lounge, where you have not only a television, but also special tools which have been designed for the purpose of helping the older people to know if they can work out their prehension and any hand problems that they could encounter in their life. So this ball has been designed to work it out and to make what they call a serious game, because it is a game, but it is serious because it will help the carers or the doctors to know if the way you are using this ball is efficient and meeting the requirements of your age. Okay, so before we look at the apartment, let's try the serious game. Okay, I think I will stop here because it's very difficult to keep the right pressure and be able to have a high score. Okay, thank you. And now Dimitri will show us the utmost model apartment, which is not here in the premises of Troyes, but in Châlons-en-Champagne. It's another apartment which has been decorated the way a real apartment can be decorated, and where people can live overnight and test all the applications and see if it is meeting their needs and if it is possible to have that at home and live with these helping applications. So we are going to see what has been done here in this residence. It is a specially renovated care house downtown in the town, and one of the apartments in this care house has been completely equipped and decorated, but mostly equipped with the applications of the Living Lab. So Dimitri will show us, for example, that there is a living room with several tools that you can guess with screens and different type of screens, but this is the way you could experiment them in a real apartment. We have also a kitchen, which is a real kitchen, where you can see there are some not only screens, but also tools and push buttons to make the different applications work and being connected to the necessary post-treatment. You also have another vision where you can see there is a small lounge here, okay, and you have the push buttons here. Here again, you have a bathroom, here again equipped for the older people and meeting their needs, but it is also connected, as we have seen. And this is the control box where you can organize your life around the main applications and the main items that are necessary in this apartment. And this is giving you a very helpful hand for your daily life when you are aging. So this is one of the examples of what the Living Lab has been doing for years here in Troyes and has been able to provide to the care houses and to the people who live in these care houses. So this is another example of what can be done for the older people. It's an example of how the silver economy is addressed here. And of course, it is an example of the meeting points, the contact points between the topics of MATUROLIFE and the topics of what they do here at the UTT in Troyes. So thank you very much, Dimitri, and thank you very much also to Thibaut Vigier, who have been able to show us these applications and to see that both in our projects, we are all aiming at the same goal, giving some helpful application for the older people. Okay, we have finished our visit and we are in front of the building of the UTT, which we have visited. But I think one last word is important. We've been discussing with Thibaut Vigier, and he told us about a possible partnership between the technology university and a design school in the area. So it's important to mix both. We know in MATUROLIFE that design and techniques, design and technologies were important to be matching and to be mixed in order to have a successful application. And it's the same purpose that they have in mind at the UTT to try to implicate a design school in their future applications and their future work. So this is one important thing. And the last, but not the least, is that if there is one day a MATUROLIFE follow-up project, like a MATUROLIFE number 2, it would be important to have partners who have the same kind of state of mind towards the elderly people, towards the design importance. And I think that UTT could be an interesting partner for MATUROLIFE too. So if they are okay, and if we start the project of following up MATUROLIFE later, well, why not have UTT on board? That's the last word. Thank you.
Thank you, Pascal. Thank you, Pascal. Point taken, well noted, and thanks for being our special correspondent in Troyes. I think your last point was a perfect transition to the next speech, because indeed the goal of MATUROLIFE was not only to be useful to the end user, but also to be desirable and fashionable. And so it'd be good to hear the perspective of a fashion specialist. So I'd like to give the floor to Ms. Barbara Shepherd, who is the head of business engagement at the Manchester Fashion Institute. Barbara?
Yes, good afternoon, everybody, and greetings from Manchester. I've decided that I'm going to let Jennifer handle all of the technology because there's a dreaded video in mine as well. But first of all, just to thank Andy for asking me to come today and talk about what co-design means for us at the Manchester Fashion Institute. As I've been introduced, I'm head of business engagement at the Institute. I've got over 25 years industrial experience as a fashion manufacturer, so that's my expertise. I'm recognized at government level here in the UK as what I call our students at the Fashion Institute, and it's quite unique. We're garment engineers here in Manchester. But my connection with Andy, I'm also chair of the steering committee for the UK-based E-Textile network. So I work across universities in the UK in this sector. So I'm probably a good contact for anybody on the call after this, if you want to connect in and just talk about the work that I do on the network, but also anything on the garment side. And it's been really good to see the work that you guys have been doing in Slovenia. It's a complicated industry sector, and yeah, here to help and really just to get involved in the work that you're doing. So I'm going to talk about two projects today because we've got 5 minutes, but my two projects are about how we're working collaboratively at the university, but also how we're doing it regionally in our sector. The two projects, one's a PPE project. This resulted right at the start of the pandemic. You'll see visually on the pictures, you'll have equivalents to this in your own country. Oh, sorry, do you just want to go back, Jennifer? You're too fast there. I'll just talk about that first. Can you go back one? Oh, you're going forward. And one more back. Thanks, that's brilliant. The first one is we actually had a call for help from our local NHS, which in the UK, that's our National Health Service. We're second on the right, that's Manchester Metropolitan University, that's my home university. We're the fashion specialists at the Manchester Fashion Institute. On this project, we worked locally with our Greater Manchester Combined Authority, and we worked with them to source a local manufacturing, because for us, we had to sort the issue that we've got. So you can see, and what I think really works well for us at the Fashion Institute, and why Andy wanted me to talk to you, is at the university, my job on this project was to pull together all the expertise that could handle this issue that we had on a particular garment of PPE, which you'll see. So we're the functional specialists. We understand engineering and how to make the garment. But a big issue that we had, and I know it hasn't been mentioned today, but it probably has been covered in your project, it was how do end users feel in the project, wearing the product. For the NHS, the garment was wrong in terms of PPE, but also the staff wearing it were terrified. They were afraid of, you know, if they were going to transmit the COVID to anybody else. And I think particularly in your project, and one of the speakers mentioned it earlier on, it's the frustration of somebody who's old and their fear. This has something that has to be considered when you're actually designing a particular product. So on my work on PP and also on the work on upcycling for Man City Football Club, I involved our psychologists at the university. So not only did we look at the redesign functionally, we also looked at it from a behavioral aspect. And I'm also working on the follow-on work with combining technologies that we have in design with technologies that we have in animation. So that's what a university can bring. And particularly on the work on PPE, we had to have a clinical benefit to anything that we did. So then I brought in our teams from biochemistry and science and engineering. But also, particularly on this project and the other project, it wasn't enough to say more research needed to be done. Like your work, we had to produce the prototypes, and we involved the manufacturers throughout the development process on the PPE. The second project, you can see it hanging behind me. It's a football project, and we like to think we're the center of the football world here in Manchester. There's massive rivalry because these products are out in hospital now. The only negative feedback we're getting is from anybody who's currently a Man United supporter. The project has worked. And this, for the Spanish members on the team, this project actually came in from an initial idea that came from Barcelona, one of the top 10 teams. Again, on this project, it was Manchester City Football Club approached the Institute. We're now working with their supplier, Puma. Again, I brought the psychologists in here because this is for upcycling for children in hospital where, again, they're terrified. And there's a lot of fear associated, both for them, for their parents, and a lot of frustration with the medical staff in terms of the finished product that's currently in use. And again, for this one, it was really important because this project is an upcycling project. And I know on the call, we have people who understand garment construction. Garment makers hate doing rectification work. It's complicated, it's bitty, they can't make any money at it. But I've worked for the last 3 years with the biggest garment maker that we have in the UK, which is Her Majesty's Prison Industries. We have over 65 prison machine workshops in the UK. And rectification isn't a problem for these guys, and cost isn't an issue because it's a controlled pricing system. So we've sorted a manufacturing setup in the UK that works really well. Jennifer, next slide, please. So this is just a couple of visuals on the work that we did. We looked at, you can see it on the right-hand side, it's the plastic over apron that everybody's seen on television. It is not fit for purpose. It does not work. And we did this work really quickly. I think that's an important thing because your project is huge. It runs over a number of years. You've got a big budget. This work was done really quickly, small budget. And there are restrictions, and I know we've got people from the healthcare sector on. There are restrictions about getting ethical approval to do this work. This work was, I was able to do it because we did it as a knowledge exchange evaluation. So I got it approved quickly. We turned this work around in less than 16 weeks. And I've presented this work in terms of its sustainability and work at in Sao Paulo. Unfortunately, I was sitting in the same desk when I really should have been on a beach somewhere glamorous. But that work was really interesting because when we redesigned it, and I know you've talked about it on the call today, we have to design sustainability into the product. So we took this existing plastic product and we worked with a plastic from Brazil that's derived from sugarcane. So I think in terms of the sustainability side of it, that has to be designed into the garment or whatever the product is. You can't at the end think, oh yes, it has to be, you know, sustainable. You have to design it right in at the start. And we worked then with our local authority to get a local manufacturer because the UK government's challenge, like everybody on the call, we want to have our own regional capability of making PPE. It's really important we can do it locally. So that means we need to be smart about who we work with and also how we're going to cost this product. So if you'd like to move on to the last slide, Jennifer. Yeah, and this is the one that gets everybody really excited because it's football. So this is for anybody on the call, you can see behind me, this is one shirt. I can't even tell you how many football teams there are in the world, but the top 10 teams produce over 19 million of these replica shirts every year. That's just the top 10, guys. So in terms of sustainability and fashion, we're quite famous globally because we're the second biggest polluter on the planet. That's not even talking about what we're doing in football. And that's before we add into the PPE tsunami that's about to hit us with, you know, how are we handling this? This product is taking end of season redundant kit. We're upcycling them and we are providing them as they're being donated by the football clubs to the hospitals in the UK. So we're working locally with the Royal Manchester Children's Hospital. We're upcycling the product. We're working it through our connections with the prison service that made over 75,000 scrubs for us in the UK. It's a controlled environment. We've no issue about child labour. I can sleep at night because I know that it's made in a factory that is sustainable. The workers are, our follow-on work here is the prisoners love this kind of work. They loved working on the PPE. We have high performance. So from a prison perspective, they're very excited about the positive impact that this kind of work has done in the UK. And hopefully we have a video at the end, and that's me finished. If you're and if not, you can see it on the Man City Club. It's on the next slide, actually, Jennifer, and then you should be able to click into it. Oh, you haven't got the one with the slide on it. Okay. Oh, have you got it? No. Don't worry. Okay, if you haven't got it, for all those football fans out there, have a look at the Man City website. You'll see the actual the collaboration of everybody involved in this. We have had UK national coverage. There's a lot of excitement. We're rolling this out now. Man City have Puma, who are the actual supplier. There's all my details and you can get a hold of me there. We've got 500 shirts for the next phase that's going out to 4 hospitals. But after that, we want to take this nationwide, because I've got one of my big children's wear hospital in Liverpool, very keen, but obviously they wouldn't be seen. Well, you can't say that, you wouldn't be seen dead in it, but they definitely don't want a Man City football shirt there. So a lot of excitement. That's the kind of work that we're doing, but co-design, but bringing in the psychology side of it, but also having the manufacturers with you so that they're, you know, I keep reading research in this area and I keep saying, yes, and now over to the manufacturers. It's too late doing it that way because then they can't cost it and they can't make it. They're key to co-design. And so are your psychologists, because how people feel in the product is really important. Thanks. That's it.
Thanks a million. Thanks a million, Barbara. Once again, extremely relevant and interesting. I'm afraid we are very late now, so without further ado, I'd like to give the floor to our last speaker for this part of the discussion, but certainly not the least of our speakers, because as we heard earlier, obviously it is also important for these smart textiles to, I suppose, contribute to an improvement of professional care services. And so we'd be interested to hear the perspective of the NHS about that. And so I'd like to give the floor to David Sandbach, who intervened several times already earlier and who is a retired NHS CEO. David, you have the floor.
Thank you. A retired NHS CEO and also a victim, because a willing victim, because I joined this group by invitation through an advert in Age Concern magazine. Okay, then let's begin. I was looking at the market possibilities for footwear, and the first thing I've got to say is that form follows function. Now that might irritate a number of people on this call, but I think designers and engineers need to understand the symptoms that people experience before perhaps they design things. And in particular on footwear, if you've got Parkinson's disease or bad arthritis in your hands, I think you'll find that Velcro is probably the best fastening system. So what I'm trying to do is just make a plea to think about the diseases that your users are going to have and what restrictions that puts on their ability. In terms of possibilities, I like the shoe. I think it would be very good in gait assessment in fall prevention clinics. In the UK, quite a lot of people who fall are referred to fall prevention clinics. A bit of a misnomer really, because they've already had the fall. But nonetheless, they're important for keeping people healthy and stopping for further falls. Other areas would be gait assessment in orthopedic clinics and physio clinics and orthotic clinics. I could see quite a lot of use for the shoes in providing the kind of data that clinicians need. Tracking people with dementia, now that's got some ethical issues around it, but if you think about it yourself, if you had dementia and you were vulnerable, would you want to be able to be tracked? I think most people would say yes. And one way of doing that is through Fitbit device type things, but basically some people wouldn't wear a Fitbit but wouldn't know they were wearing a device in their shoe. The other thing is around, well, what do people wear indoors? And basically old people like me wear slippers more often than not. And you'll see on this slide a group of nurses with anti-slip socks which are red. Now, they were actually used in a hospital. This picture several years old, and they were used by nursing staff to be able to spot patients on their ward who were prone to falling. That was the original intention. But if you think about it logically, could we produce something like these red socks, which have a tracker, pulse monitoring, plus some of the functionality that we've seen in the shoe? I just put that out for consideration. Next slide, please. Next slide, please.
Can you see it?
Next slide, please.
It's, hang on. I don't think it's, let me stop sharing. Start again. Can you see it now?
I can see it. Can you do the slide 2, please?
Oh.
I think you need to stop enable editing first. So if you stop sharing, click on that, enable editing, and then.
Okay.
Oh, sorry, back.
First. Okay.
Yeah.
Right.
Yeah.
The smart chair beyond the living room. One question is, can this technology be applied to wheelchairs? In the European Union, the stats say that there are about 5 million wheelchair users. One of the interesting things about that group is they probably have at least one long-term condition, maybe a lot more, and being able to monitor their health from their wheelchair, I think, might be an interesting question to ask. What about a smart hospital chair for automatic patient monitoring? Anybody who's been in hospital know that you spend a lot of time in bed, which is a bit boring, to say the least. But I can't see why we can't have a chair like the one that was demonstrated for patients to sit in next to their bed, and data is automatically collected about their state, and for example, pulse rate and so on, temperature, a lot of things that a nurse has to come round and check every so often could be done through a smart hospital chair. And then finally, I'd like to say about the chair itself, I think most people will be familiar with the phrase, "Beam me up, Scotty," from the films. I think that the smart chair is in fact a platform for quite a lot of technology which could help people and their health state, their health status. For example, a chair could include a pulse oximetry, so we can check the blood oxygen levels. It could also have a component in it to hold a blood pressure machine, and I think possibly even an Alexa voice control system might be a good idea. So there's plenty of things we can put into chairs. There's in fact quite a lot of technology that could go in there to help people be monitored, medically monitored, their data stored, and then their data used to plan the medical management. Next slide, please. Yeah, smart digital fabric beyond the t-shirt. Obviously, hypothermia detection, maintain body temperature. I think heart rate monitoring could be included, and also the vertical horizontal detection system. There's a piece in The Guardian some time ago by Owen Jones, which pointed out that fuel poverty is in fact to blame for a lot of deaths in the UK, and the t-shirt, or the idea of a garment that keeps people warm, would be one way that we could fight fuel poverty in certain areas. There's also other areas that we could use this technology. There's such a thing as contactless medicine. In other words, where the patient is at one place and the clinician is in another place, and they don't actually make any physical contact. And I think the t-shirt could be well used in that kind of context. It could be used in industry, for example, where workers have to go into cold storage areas. Also in emergency services, where you see ambulance people hanging around in the cold and the wet, needing to keep warm. Other areas include surgical drapes. For example, people having a knee or a hip operation could have a surgical drape on the upper part of their body to keep them warm and comfortable. Another area is neonatal units for preventing hypothermia amongst children. And then using leisure clothing, for example, skiers. And I suspect that would be the big profitable market, because skiers tend to be the well-heeled bourgeoisie and have plenty of disposable cash to buy clothing that keeps them warm when they're out skiing. Indeed, that's exactly what my daughter, who is a keen skier, said to me a few days ago. Next slide, please. Well, I've got to be in my bonnet about this. The data that is collected is my data, and I wouldn't use any of these products, excuse me, unless I know where the data is being stored, and only if anyone doing research on my data basically seeks my permission. Data security must be considered early on in product design. Some data from the BMJ there is 19 out of 24 of sampled apps share user data outside of the app. Well, who are they sharing it with? What for? And who's got control over that? These are questions that the engineers and designers must ask Otherwise, you'll get a situation whereby there is big resistance to your products because people won't trust them unless they know where that data is going and how much control they've got over it. The product will not sell. Thank you very much.
Thank you, David. Many important messages there. I'll just not, I'm not trying to summarize your intervention, but from our perspective, 3 very important messages. First of all, the products developed as part of MATUROLIFE are nice, but there's probably a lot of potential yet to be unlocked, and that's probably another signal for maybe MATUROLIFE Chapter 2. I'm just saying. Another one is that ICT is a great tool to support people, but obviously in no way it should replace, and also to the extent possible it should be personalized to the actual needs of the end users. And your very last point on data protection, I think is a key point, because indeed in the group we represent, Informal Carers, this is something we often hear in terms of how is the data collected, being used, and where is it stored, and to what extent is it safe. Thanks a lot. We'll move on to the last intervention before a small Q&A, probably shorter than expected. Laura Christ is a member of our stakeholder representative panel and the advisory board, and she's also a social gerontologist and I would say a knowledge broker between research and policy. So Laura, the floor is yours.
Yeah, just Jennifer is sharing the screen for me. Well, thank you very much for that, Jennifer. And thank you for being able to give a short presentation. I'll keep it very short. I'll make it shorter than, I'll show the slides, but I'm not going to go through all the points because there's not much time left. I feel honored that you say Laura Christ, but that's too much honor. It's Chris.
I was wondering.
Yes, yeah, I come from high places, yes. So let's start. Could you go to the next slide, please? Yes, as you already said, I'm a social gerontologist. I'm a member of both advisory groups. The one is the expert advisory board, and the other is I'm also a stakeholder representative, you could say. And maybe there is also a third perspective. I'm, as I age, and having had some health issues these last 2 years, I think I could also say I'm looking at the MATUROLIFE project from a user perspective. But these different groups, the advisory board and the stakeholder representative panel, they overlap. My background, maybe, I don't know if I'm suitable to be in all these, to talk from all these perspectives, but in a way, I think I am. The social gerontology part makes that for 30, almost 40 years, I've been active in the field of social gerontology, especially on issues as ageism, age discrimination, but also from a gender perspective. But the most important part is that I've always been working on bridging the gap between knowledge, theories on aging, and practice. So that's exactly what's important for the MATUROLIFE project too. But it's always been, as we say in Dutch, a common thread in my work. I'm also a member of an older women's network, which is a member of Age Platform Europe. And as a member of the network, I've been involved in several Erasmus Plus projects that have to do with, well, yes, it's on the slide. You can see the issues. And they have to do with co-creation, with engaging people and acknowledging and valorizing the knowledge and skills of especially people 80 plus. And like the Invisible Talents project, encouraging and recognizing the contributions of people 80 plus, which is also an important perspective, not medicalizing, not seeing all the people as vulnerable and frail and dependent. So can we go to the next? Yeah, I think I don't have to go into detail. It's clear these two different perspectives, which also have an overlap. And this meeting now, we've heard many examples. The last speaker, David, showed how the External Experts Advisory Board operates, and the critical fringe role also plays a role in this meeting. So I think I don't have to say any more about that. Can we go to the next slide? Again, I can say, I'm not going to take you through all these points, just referring to speakers like Catherine Mercadier, who also said active aging, it's not just people being frail or dependent, but active aging is also participation, co-design, involving, engaging with people as social actors, active agents in urban space. And one of the points raised in meetings with the EEAB is be aware of hidden ageism and victimization and medicalization, etc. Take into account the heterogeneity of all the people, the differences between men and women, etc. And yeah, the issues mentioned. One of the things I think is important, simplification is key. Keep it simple. Simple is okay. However, the MATUROLIFE project shows that realizing simplification in such complex processes is very, very difficult. I think, well, we can go to the next slide, say one or two things about the critical friend. We've also heard this in the presentations. Maya showed how important communication is and co-creation design workshops. In all parts of the MATUROLIFE project, we've seen co-creation and communication. The only thing is that the COVID-19 crisis has prevented many workshops. So I'm hoping that there'll be a second life for the MATUROLIFE project, in which some further testing and involvement of all the people, of the users, still can be done. I think that's extremely important to do that. Yeah, I think I'll leave it at that. The only thing I wanted to say is, the last thing I wanted to say is, it's been very interesting, the MATUROLIFE project, and I very much regret that the Netherlands is not part in. So I hope in a second one, the Netherlands can be involved too.
Not yet, but who knows? Thanks a million, Laura, and thanks a million. It gives me a chance also to thank you as a member of the Stakeholder Representative Panel and Advisory Board, and by extension, all of the members of those two board and panel. It's extremely useful, obviously, to be able to test ideas and get feedback, and thanks a million for being our critical friend, as you rightly said. Now I'd like to open the floor one last time, maybe for 5 minutes. Is that okay? Maybe for the remaining questions or comments, if any.
Kenny.
Is there any question? No? Everything clear? Everyone is really tired? Yes, David?
One of the things I've noticed is a focus on physical health, if you like, and I think it wouldn't do any harm to include in some of the products, particularly the ones with the shoes where you've got the app and all the rest of it, some collection of information about the user's mood and mental health. Has anybody seen examples of mood apps? No? Yeah? Well, basically, there are a lot of apps on the market which people can use to record their mood on a particular date and time, and the data can in fact be used to help with mental health issues. And clearly, in all of the products, there's nothing about the person's mood, and that might be something people should give some consideration to, bearing in mind mental health issues affect around about a quarter of the population at any one time. So I'd just like to make a plea for a mental health component in these products. Thank you.
Thank you, David.
Just to one addition comment, it's we do have we do ask how do you feel, and we do collect that data. Maybe it wasn't presented in the presentations.
I think we briefly saw it when Javier gave his presentation. The first slide was, how are you feeling today after being connected? Any additional comment or question?
Yes, I was, sorry. Regarding the last slide of Laura Chris, that was asking if to clarify intended target audience for the Fornetor prototype, is the user or is the family member the target user? I would say that it's a team, because it's not only for the user, but the relatives, the family is going to be to have a good use of the sofa as far as they are in contact, in a closer contact with the relatives. So I think it's a partnership between all the members of the family, and also the caretakers as well. Because probably a final user, an adult, would consider some of the features as not very useful, but maybe the family, they see the usefulness of the features.
Thank you. David, you had an additional comment?
Yes, a comment, yes. My next birthday, I'll be 70, so I'd just like to thank you all for all your efforts to make sure that I have a long and happy old age. Thank you very much.
Thank you, David. And next time we'll make sure there's a place where you can store your beer, we promise. So with that, I'd like to conclude then the event, and thank you all very much for your active contribution today, and thanks for your time. I will now give the floor one last time to my colleague Andy Cobley, who will help me land safely and wrap up this event. Please, Andy.
Okay, so we are running a bit late, so I will keep this brief. I mean, there's been a lot of really useful comments that we can take from this meeting. We've obviously got our final consortium meeting coming up in July with our project officer and monitoring officer. So this has been quite a good test run for us, and some of the critiques we've had are really useful, and we'll take them forward. I'm very keen, I'm very happy to hear the keenness of people for a MATUROLIFE 2. I'm not sure whether Coventry is going to lead that, but if anybody else fancies doing it, then that would be great. as I said, there's been a lot of very interesting comments. I think one of the things that we have thought about in MATUROLIFE, but perhaps we haven't really highlighted it perhaps enough in this presentation, is sustainability. That's been mentioned by a few speakers, and perhaps that's something we should take away, that we need to highlight that when we come to talk to the Commission. Okay, so I'd like to finish off by thanking people. First of all, obviously, need to thank the European Commission for funding this project. I'd also like to thank our speakers, particularly our external speakers. Catherine Mercadier-Saflix, I'm sorry if I murdered some of your surnames. Laura Kreist, Andy Cripps, Barbara Shepherd, and David Sandbach. Thank you very much for all your contributions. Really appreciate it, and for giving up your time today. The MATUROLIFE Consortium speakers, I mean, I'm going to mention the speakers, but obviously the whole consortium has contributed to the work we've shown today. There's a lot of people and a lot of companies that we've not actually mentioned, but have made a huge contribution to the project. But for today, I'd like to thank Neil Chilton, Ana Adele Lamora, Carlos Gonzalez Monos, Javier Cortes Camaros, Maya Godkovich, and also Pascal, who made a couple of appearances in our video, as you would have noticed. I'd also like to thank the organisers of this meeting, particularly Gule Ozkan, for arranging everything with Eventbrite. Then there's Jennifer Quinn, Narinda Baines, and Louise Moody, and Vera Horman. They all helped with the agenda and arranging speakers and planning the event. And lastly, but not least, of course, it's Stacey, sorry, Stacey, for monitoring today's events and chairing the meeting. So other than that, I'd just like to thank everybody for attending the event today, and thank you very much for all your contributions.
Let me take a picture, if everyone can open their cameras, if you don't mind, you would like to take a picture.
Is it done?
One more. Thank you.
Brilliant. All right, thank you very much, everybody, and yeah, have a good rest of your day.
Thank you, everyone. Stay safe.
Thank you. Bye-bye.
Thank
Bye.
you. Bye.
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 Goodbye. Thank you. Take care.
Bye.
Take care, everyone.
Bye. Thank you.
Thanks.
Bye.
Goodbye.